Can we start with our first talk, Arun? Hello. I think you are on mute, Arun.
Yeah, sorry, I was on mute. Thank you, Arun, so much. So thank you for your time also for the sign up for keynote speaker. Okay, so maybe let's get started. So first talk, right? Like we are going to give about performance testing. So quickly, let me share my screen. Just a minute. Okay, can you able to see my screen?
No.
Now?
Yes, it's visible.
Yeah. Okay. Okay, fine. So let's get started for the first talk. So it's about performance testing using K6. So here in this session, like we are going to see how you can do a performance testing for an API. Either it can be a get call, post call, anything else. So like how we are going to do the performance testing and what are the metrics we can measure measure the performance for an API. So like myself, Arun Kumaraswamy and Deepali, we are going to take over the session. So like I am Arun Kumar, like I'm having around 6+ years of experience in testing with 3 years of experience in working experience in ThoughtWorks. Deepali, can you give a quick round of applause?
Yeah. Hi everyone, my name is Deepali Patil, and I am here for 1.5 years in ThoughtWorks. Yeah.
Yeah. Maybe, yeah, we can get started. So maybe like I'll just give a quick round of intro about the talk so that like we'll go into the slides. So here like we mostly will look into the basic concepts of performance testing using K6. So K6 is one of the performance testing tool, which is available both in open source and cloud. So here like we'll have some basic set of slides and then we'll quickly move on for the hands-on demo. Like Deepali will get into through the basics of performance testing. Then I'll be taking over for the hands-on session. Yeah, maybe Deepali, you can get started. It's over to you.
Yes, sir. So we will see what is the performance testing. The performance testing is used for the testing speed, response time, stability, reliability, and resource usage of a software application under particular workload. And the main purpose of the performance testing is to identify and eliminate the performance bottlenecks in the software application, and it is also known as perf testing. And the main attributes of the performance testing are scalability. So scalability determines amount of load software product can handle at a time. And second one is stability. It determines whether the software product is stable in case of varying workloads. The next one is reliability. It determines the software product is secure or not. And the last one is speed. It determines whether the software product responds rapidly. And so now we will see the process of performance testing. So the performance testing includes total 7 steps. The first step is identifying the test environment. So whether it's dev environment or QA environment, and also identifies the hardware, software, network configurations and tools available. It allows for the testing team to design the test and identify performance testing challenges. The second step is identify the performance acceptance criteria. So in this step, you should know about the criteria. So which platform needs to support and how quickly it needs to respond to those requests. The next step is plan and design performance test. So during the planning and design phase, it defines how usage is likely to vary among end users, and along with the scenarios to test the showcase typical visitor use cases. The next step is set up the performance testing environment. So during this step, you will have to configure and arrange the tools and other resources to perform the test. So the next step is test the design implementation. So this step involves testing the test environment for potential bottleneck problems. The next step is run the test. So all your prep work is about to pay off. It's finally time to run the test. While running the test, monitor and record platform performance data for analysis. The last step is analyze and retest. So this step means examine the test results both during and after this test. So if the testing platform is experiencing a problem like CPU or network bottleneck, stop the test and address the issue before repeating the process. Yeah. So the next slide, can you move to next?
So adding on top of your comments, so so it's moreover like a normal, like how we do for a UI testing, right? Like if we are going for UI automation, so we'll just do like in which environment we need to do, like what are the criteria we'll need to set, and we will be planning and designing the test cases, implement the designs. So similar kind of like, it's more or like, if you see this process, it is similar to what we do with the UI automation, but the only thing is like the second step. So what are the performance criteria we are going to define? Which is going to define your API will be it is a performance. It's okay with your performance and it is efficient. So this is the only difference between the normal UI automation process and when it comes to the performance testing process. Yeah. So let me move on to the next one. Yeah.
Thanks, Arun, for adding. So the next slide is introduction about the K6 performance testing tool. So the K6 is an open source load testing tool for testing the performance of APIs. So with the K6, you will be able to regress the performance and have problems early so that robust systems and apps can be built. There are two different versions of available users. The first is open source and it is for normal uses. And the cloud version is available for tries to scale up our test. So the key features of K6, the first one is it is developer friendly CLI tool. The next is it is scripted in JavaScript that supporting to both local and remote modules. And the last one is it is having inbuilt checks and thresholds for objective automatic load testing. Yeah, over to you, Arun.
Yeah. So next is so we are having some general use cases here. So general use cases is like with the particular tool, like what are the use cases we can do, like what are the kind of testing we can do. So here with K6, like we can have, we can do like, these are the most two common things we can do. So one is the load testing and one is the performance monitoring. So load testing is nothing but like, as many of you know, it is moreover like checking the system resources with high load, and let's say like I have an API, let's ramp up to some 100, 200. For example, let's take an e-commerce site, like we have some big billion day sale. So like we will be getting, we'll be very curious like how they are doing, how they are scaling and how they are doing the performance testing. So moreover, they will be mostly like they will be doing a load testing there. Let's say like I'll be load testing and spike testing, those things and all they will be doing that. Let's say like with 1 minute 100,000 users, next to 2 minutes it will be like 10,000 users. So this is what a load testing mostly will be doing. And next is the performance monitoring. So with K6, so we have two variations. So one is cloud and one is open source. So in cloud, right, so it is a licensed one. So you will be given a cloud for you, and there you can visually view everything. What are the performance metrics and all we can handle, like in inbuilt performance metrics, K6. So everything like we can handle that. But in open source also, they are providing some performance monitoring. So with you can integrate your results, the performance results with the resources like integrated sources like Grafana with InfluxDB, AWS CloudWatch, JSON, stats ATSD, etc. So these are things, these are two main things we are opting out for K6. And then what K6 does not. So let's say like, so let's say like if I take a tool Locust. So Locust is a performance testing tool. So where what it will do, right? So you need to launch a local host, and then you need to run your tests from there. So that is what we need to do. But in K6 we don't want to do like that. So it will run with its own CLI itself. So that is what the K6 does not do. So we can run everything in its own CLI, like you can integrate a node script, and then if you just run the command, right, that is command, right, it will automatically run and provide you the results there in the terminal. Yeah. So if you remember, like I was telling about some inbuilt metrics in K6. So those inbuilt metrics are, so like for particular API performance, so K6 is providing some inbuilt metrics. So these are the metrics, and these are the metric type. So there are 4 metric types: counter, gauge, rate, and trend. So the name itself says counter is like added values. Gauge is nothing but like we can get the metrics of min, max, and last values. Rate is moreover like a percentage or percentile, percentage, and trends, right? Like it mostly comes with average and then percentile, those kind of things. So these are some of the metrics K6 is defining here in for open source and cloud. So we use virtual users max, iterations, iteration duration, drop date. So moreover, like maybe like I can quickly walk through what are this we use in the sense the virtual users. Like we are going to have some virtual users, right? So like 1 user, 5 users, 20 users, 100 users. So VU max is the maximum number of possible virtual users, active virtual users. And iterations is nothing but like how many times I have executed the particular API, that is the iteration. And iteration duration is a summation of the average of all the iterations. And then drop the iterations is nothing but like if any network issue happens in between, let's say like I'm going to use for 20 virtual users a particular git call, in between like there might be some network issue. So those things will be considered as drop the iterations. Then remaining and all, you might have the data received, sent, HTTP duration. So these are the normal terminologies. HTTP duration is nothing but like how much time it is taking to send the request and receive the response. And here there is one more thing called checks. Checks is nothing but checks are inbuilt in K6, which are used for asserting. You can assert the status. You can assert the status of a particular HTTP API call. Like let's say like if I'm sending a GET call, you can assert the status whether it can be 200, 400, 500 like that. So these are the metrics we are going to use in K6. So now we'll go into checks and thresholds. So checks are nothing but like I have already told you, right? Like those are mostly like an assertion. So like you can assert whether the response code, assert the response code, body or length, like everything you can assert here. And this is the syntax for using check. So everything like in hands-on, like I will show you how we have implemented, but this is the syntax. So this is the syntax for doing the checks. Thresholds is nothing but thresholds are like you can say like how to measure the criteria, the pass or fail criteria. So you can use thresholds. So there are inbuilt thresholds in K6. So like what are the metrics we use? I have told here, right? Like what are the metrics they have defined? So with all the metrics, with some of the metrics like HTTP, mostly with all the metrics, right? You can use the thresholds. So thresholds will be mostly will be used to analyze the performance metrics, whether your test is passed or failed. So for that purpose, not the test, the particular API call with particular load or particular stress, right? So with that particular configurations, your API is getting, if your API is performance efficient or not. So that is what we will be doing with the thresholds. So you can say like, that is what we have mentioned here. It is used to verify the pass or fail criteria of the system under test. So this is the sample for thresholds. Like this is how we declare a threshold. So I will show you in the hands-on part. Yeah. So Deepali.
Yeah. So now we will see the performance testing types. So we have load testing, stress testing, endurance testing, spike testing, volume testing, and scalability testing. So performance testing with K6 is a smoke testing, load testing, stress testing and the Arun, your screen is not visible.
Now is it visible?
Yes, yes. And the last one is soak or endurance testing. Yeah. Now we will see this in detail with example. Yeah. So the smoke testing, it validates the stability of our software application, and it is used in initial stage to ensure that the critical function of the program are working or not. And for example, two virtual user looping for 2 minutes.
Yeah. So adding to this, like, so smoke test is normally like what we do for a normal build, right? So if you're deploying anything to an environment, we'll just see whether all the functionality is working fine. So that is what the smoke test also here in performance. Let's say like if you're going to, if we have set up an API and we want to do a performance, a smoke test with minimum load, like let's say like for example, like we have given, right, 2 users for 2 minutes. That means for 2 minutes, the 2 virtual users will be trying to hit the request and get the response. And for that, like we will analyze all the metrics, like how it is working. Yeah.
Yeah. And the next one is load testing. So this is a non-functional software testing process, and it determines how the software application behaves while being accessed by the multiple users simultaneously. So here we have example like ramping up the users from 1 to 100 in 5 minutes, and then stay with 100 users for next 10 minutes, and then ramp down to 0 users in next 5 minutes. So yeah, the next one is stress testing. So the stress testing is a sorry. So it is accessing the limits and stability of the system under extreme conditions. So for example, we have like ramping up the users from 1 to 100 in 5 minutes, and then stay with 100 users for next 10 minutes, and repeat the same for the some stage, and then ramp down to 0 users in next 5 minutes. So next we have spike testing. So the spike testing means this is variation of stress test, and it does not increase gradually. Instead, it will spike to extreme load in short span of time. So example, we have like in real time, right? Let's say about the offer sale in e-commerce site. The users may come in at spike, let's say within 2 minutes, there will be a spike of 1000 users, and again next 2 minutes, there will be 2000 users. And the last one is soak testing. So the soak testing means it is used to measure performance of a software application under a huge volume of load for an extended period of time. And example, we have soak test is measured in hours. Let's say our application started with 100 users for 2 minutes, and then stay at 100 users for 1 hour 56 minutes, and then ramp down to 0 users in 2 minutes. Here the system stay at 1 hour and 56 minutes with 100 users by hitting the request constantly. And now we can find out the memory leakage, insufficient storage, or and infra issues here. Yeah, that's it about the testing types. Arun, do you want to add anything?
Yeah. So on top of that, for soak test, right, like mostly like so to verify the withstand of our API. Let's say like, so let's take an real-time example. So if a particular, let's say like in amount transaction, if a particular account is getting hit for continuous time, so the account will be get blocked. The transactions for that account will be getting blocked. So similar way, so that like I'm not comparing that one. Similar way, like if we have some API with the gateways. if you have some API with the gateways, right? Like let's say I with some API firewalls and all, like I'm going through the firewalls with authentication. If I'm trying to hit it for 1 hour or 2 hour continuously, the 100 users, right? So there you can find out like what are the other kind of issues. Like there can be an insufficient storage, and there can be some infra related issues. The system may get down. So these are the things we can verify in SOAP test. Yeah. So yeah, so next we'll go into the demo part. Yeah, so just a minute. Yeah, so here like I'm going to have a demo of K6 with the Grafana and the InfluxDB integration, so that like you can see some visualized performance metrics within your test codes. And also like, so this is a basic framework setup. Like we haven't looked into much into this concept, so that like so in our future enhancements, like we are planning to push it as a Docker image, and we'll be having a same port for both Influx and Grafana. We'll be using it for the same port. So now like if each and every time, like if I build the Docker Compose file, like I need to change the port numbers every time. But in our future enhancements, like we are having this kind of plan, like how can we push it as a Docker image and make it run every time, so that like once if I pull that image, so I can run my test. So these are our future enhancements. So I have given the repo link also here. So maybe like I will quickly start off with the testing, with the demo part. So installation, regarding K6 installation, right? So it's very simple here. So you need to give brew install K6, so it will be installed into your machine, and you need to install the InfluxDB and InfluxCLI. So this is for verifying some. If you are going to like the InfluxDB and Grafana, you can do it. You can install it in 2 ways. So one, you can use from your Docker image in existing Docker image. Add it in your Docker Compose file and run that Compose file, or else you can install in your own local. So what I would suggest, right, installing in your own local, sometimes you will forget the password, or you could not, sometimes like the same port you will be using for some other thing. So instead you can use a Docker Compose file like this. So like we have a Docker, we have a Docker Compose file with Grafana image I have given. So now the latest Grafana image is enterprise. Initially, like they have with versioning. So now we are going with this particular Grafana enterprise. I have given the container name, and here is the port. So we are going to use the port. So by default, Grafana will be using 3000. So I'm going to map it for 3005, so that I can use my Grafana dashboard here. And similarly for InfluxDB also, like so this is the stable version which you can use for all your InfluxDB Grafana integrations. And then here also, like I have given my InfluxDB username and password. So if I give an environment variable like this, right, so automatically whenever you install, if you Docker Compose this file, so with your username and password, it will create one access for you. So this is what the Docker Compose file looks like. Yeah. So next is like, so I have in the README file, right? Like if you are going to have this repo, right? Like normally you can clone, like I'm just explaining, if you're going to start from the scratch, what are the things you need to do? So you can have a node package. So for running your test, or else you can use yarn, anything, whatever you are comfortable, the runner, right? You can use that one package modules. And then, so this Influx installation from node is optional, because like each and every time I could not go into the container and create my DB. So what I have written, so I have written a simple JavaScript code to connect to my InfluxDB with my required DB name. Next is the next is the Docker Compose file command. So this is the command we are going to use. This will start the images, like it will build the images and it will start the ports here. So here we are going to use 3005. Then we need to log into the Grafana dashboard. So with initial credentials, it will be admin and admin, and then we can change your username and password. Okay, so then these steps are for setting up your, like I will show you in real time, but before that, like I'm just walking you through like what are the steps. Then what is the thing, right? Like Then what is this, right? Like you are going to set up the Influx. You wanted to connect your Grafana dashboard with your InfluxDB, right? So this is what this one. This is what we are going to do. So here, when you are going to configure, right, like you are going to give your system IP with the with the port whatever we are giving. So whatever we have configured here, and then we need, or else like if you are going to, you can also try with your container name. So these are the two ways you can connect your Grafana dashboard with your InfluxDB. Then next is the for creating InfluxDB. Then yeah, so this is what I have given. So I have create, or else like you can go with this method, or else like you, okay, I will show you that also there when I was doing the hands-on. And you need to provide when we go into the Grafana dashboard, right? Like you need to provide the InfluxDB username and password, InfluxDB and password, and we need to give, and then automatically like your Grafana and Influx will be connected. Then now you need to configure your dashboard panels now. So this is what we need to do. So like these are the things I have given. And one more thing, like why Influx with Grafana? So InfluxDB is like a time series DB. So you can, so everything will be converted into a time series, and then you can also you can also retain, you can redefine your retention policies also. Like you can create a 1-year policy for that particular DB. Let's say like here I'm having the DBS QA community. This is retention policy for 1 year on QA community, so that like for 52 weeks, whatever the metrics you are doing, right, that will be retained. So you can so when I show you the dashboard, right, you can able to see a visualized view on like what are the time series we're. So this is what the basic overview of the framework. Maybe like I can start showing you the scripts here. So this is the smoke test. Like if you remember, Deepali was telling, smoke test is just checking an system with minimal load. So here I'm going to use one virtual user with 1 minute. That is what I have given. And then HTTP request duration. So here, right, 90th percentile of request should be less than 4,000 seconds. That means, so 90% of the request should be less than 4,000 seconds. That is what we have given. So here mostly it will be transferred into millisecond. Like more of the things it will be converted into milliseconds. That is what we are. That is what the threshold. So whatever thresholds you can have, right, you can add it here. Let's say like I am going to have checks. So this is what one of the metric here, and you can give HTTP. Sorry. Request failed. So these are the things we can add it as our thresholds. Yeah. So this is what we can these are things we can do it in threshold. And this is one of the dummy URL with username and password for logging into a particular website. So this is what the post call. So we are doing some authorization, and then like I am just verifying whether I have retrieved a successful JSON or not. So this is what the simple script looks. Okay. Okay. Okay, fine. So now let me quickly go in, like let me start with the configuration part. So this is what we are going, sorry. Let me start. Then, okay, so now my first command, okay, fine. So let me check whether my containers are running already. Yeah, so like already my containers are running. So what I'll do, I'll just stop the containers. Okay, fine. So now I have killed all my Docker containers. Okay, so first step is, if you remember, like I was telling, we need to run our compose file, docker compose up -d. So -d is like detached mode. So we don't get the logs continuously there. So like, let's see now. So like I have executed it multiple times. So what it will do, so it will normally create and pull the images and start running the containers. But if you're doing it for the first time, right, like you can able to see like what are the steps it is doing, what are the images it is pulling. So now if you see here, I have my two containers running. So one is the Grafana and one is InfluxDB. Okay, so it listens to Grafana, listens to 3000. By default, it is in 3000. It listens to 3005, and it is 8086. It listens to 8087. So this is what we have done now. Okay, so now next step, before running the test, we need to configure our dashboards, so that only like we can able to see the metrics. So for that, I will navigate to localhost 3005. Okay, so like already like in my machine, I have set up it. Maybe like let me, yeah. So, okay, fine. So already like I had the instances already, right? Like it is running. So this is what the dashboard looks like. This is the Grafana dashboard. So next step, if you remember, the next step is like integrating our InfluxDB with our Grafana. Okay, so now for that, we need to go for data sources. So like if, okay, maybe I will remove this one. Delete this so that I can show you handy. Yeah, so we need to add a data source. So I'm going to use the InfluxDB data source. Okay, now you can give a name here. Let's say like I'm going to give a name for my DB connection, a name for the, not DB connection, name for this particular connectivity. So Vodka, I'm going to give Vodka here. Then I'm going to give HTTP : my system IP 192.168.1.35 : so where we are running our InfluxDB, we are exposed to 8087. So I'm giving : 8087. Okay. Then we need to give a database name. So you can do it in two ways. Like I have already said, either you can run this from here. Let's say like I will run Vodka. So either I can run the script from here. Okay, finished. Or else what you can do, you can go into this particular container, Docker. So using this command, Docker exec, sorry. Okay, Docker exec, it went into this influx. And then if you give this command influx, it will be connected through your localhost 8086, and you will be redirected to the InfluxDB shell. So now if you give show databases, now you can see I have created a database called Vodka. Here also you can create your database. Create database and the name. Let's say like 29th Vodka. Semicolon. Oh, okay, sorry, it won't take the numbers. Let's make it as Vodka digital. Now again, if you give show databases, it will show Vodka digital. So now we can use either Vodka or Vodka digital. So these are the two databases we can use here. So let's say like I'm going to use my Vodka digital. Okay, and if you remember, like I was mentioning you need to provide a username and password in the InfluxDB environment. So same username and password for the connecting to the DB, you need to give here and save and test. So now your data source is updated, and now whatever tests you run here, right? It will be saved in Vodka digital database, and it will be reflected in your dashboard. So this is what we have done now. Okay. So now what is the next step here? So next step is like you wanted to create your own dashboard, right? Like you have done the connectivity, you have created everything. Now you wanted to visualize your database for monitoring purposes. So let's say like I'm going to add a panel. So you can give a name to your panel also. So you can, let's say like duration time. So this is mostly for our HTTP request. Here you can select your type of visualization. Either it can be a time series, or either it can be a broad chart, a gauge, a stat, anything, whatever you want, you can share it here. So like maybe I can show you a time series now, And now you need to select your data source here. So what is a data source? So I have mentioned it as vodka. So it will be selected as default here. Then you need to select your metrics. So initially you don't find any metrics here because like we haven't executed any of our tests, right? So there won't be any metrics here. So let me just save this dashboard. So let me save this dashboard. Okay. Then we'll go to our script and run this basic smoke test script. Okay, like I'm going to run this. So here we need to like, yeah. So, okay. So before that, like you can visualize your metrics in multiple ways. Like I have told you, right? JSON, statsd, a text file, sorry, a CSV file, and then you can integrate with your AWS CloudWatch. You can integrate with your data watch, and then you can go with the statsd. So similar way. So here also you can have multiple the visualization can be in any type. So here I have given for JSON. If you see here, I have given in a JSON, I have given in a CSV type. And then, so for influx and all, like I have given InfluxDB. So this is the command to run a script, K6 run -- out. What is your output type? Like either if you want it in CSV or JSON or InfluxDB, you need to mention here. So now maybe I can show a sample for JSON and CSV. So this will be, and you know, right, like a normal JSON file and a normal CSV file. So it will be like this only, but we'll go more into the visualized one. So here, right, like smoke, in the smoke, right, InfluxDB equal to, I wanted to mention InfluxDB, which is equal to, then I need to give localhost : in which port I have exposed. So I have exposed from Docker container with 8087. So I wanted to give that port here / my DB name. So here, what DB name we are going to use? So we are going to use Vodka Digital. Okay, so let me choose it to Vodka Digital, and then the path to the test script. So this is one of the sample smoke test. Let me run this. So let me give exit, then npm run sample smoke. So now if you run, right, like you can able to see K6 haven't launched anything in the browser or separate instance or anything. So it is running in its own CLI itself. And also you can see this is the script. It is executed in local. If it is in a cloud, right, it will be mentioned as cloud here. And then output, right, like it will show. We are going to provide our output in InfluxDB, which is connected to this localhost 8087, where we have, which is what we have configured in our Grafana. So now if you go here and click on edit, you can able to see the metrics here. Now you can able to see, right? Let's say like I'm going to give HTTP duration and save it. Okay. So similar way, you can add multiple queries also. Let's say like I'm going to add HTTP receiving. And also you can select your aggregators also. Either you can go with aggregators, or else you can go with some selectors like minimum, max. So these kind of things and all, you can do it here. Predictors, aliasing, math functions. So everything you can go here. Let's say like I'm going to go with the selectors. Sorry, I'm going to go with the aggregations. I'm just giving a mean value here. So now if I apply here, you can see some small, okay, let me say in last, you can, yeah. So this is what I was telling you. You can able to visualize till last 5 years and all, and previous year, and this is what. So I'll give for last 5 minutes. If you see here, now you can, now you can see the spikes here. Okay. So in more detail, okay. So we'll run another one test. So let me take a load test. So, okay, I will just give it for this like this. Okay, gradually I'm increasing. So totally in 4 minutes, I'm going to run for 15 virtual users. So let me run the script. So if you see here, this is the command I'm going to execute. So before that, like you can see here, the checks, whatever we have used, right? Login successfully and retrieved crocodiles. These are the 2 checks I have given. And thresholds, like we have given a threshold for HTTP duration failed. So HTTP failed should be like since it is 0%, right? Like thresholds are also passing. If you see another threshold we have given for HTTP request, so it is taking only 460 milliseconds. So for example, okay, let me, if we try to, like, if we wanted to fail this scenario, right? Let's say like our HTTP threshold was for 90th percentile, it is for 460 milliseconds. So maybe I'll go here. Let's say, where is my test? Yeah. So here, just to give, it should be like, it should be less than 300. I'm just giving like this, and let's see what happens here. Let me run this again. So like for one virtual user, for 1 minute, I can able to complete 75 iterations. That means 1.24 iterations per second I can able to do. 150 HTTP, 150 requests I have triggered. 150 times I have used the login site for in 1 minute for one user. So that is what these are things it has been mentioned here. And then we can have, okay, let me wait for this to complete. Okay, 52, because it is ramping down. So if you see, there are no interrupted iterations. So sometimes there might be network connectivity and it may get failed, right? Yeah. So if you see here, some of your thresholds are getting failed. So why? In the sense, if you see here, we have given 90th percentile is 458 milliseconds. But what I have given here, I have given it should be less than 300 milliseconds. So my threshold is failed. So then here we need to take a call, like whether we need to do any performance fine tuning for our API, or else like we need to check whether the connectivities and network connectivities are correct. And then like we need to retrigger and see how it works. Because if you see here it was for around 460 milliseconds. Here also it's around, so average by average, you can say my my HTTP duration is taking around near more to the 90th percentile is near to 460 milliseconds. But average it sends, it shows 374. And also, yeah, so moreover it is same, like 2 to 4 milliseconds difference. So this is how we can, this is how the failure test case looks. And now if you go and refresh your dashboard, right, you can see some more spike here. Can you see some more spike here in last 5 minutes? So let's say in last 15 minutes. Yeah, so this is how it looks, our dashboard. Yeah, so now we'll run a simple load test and see how it works.
Arun, we have to change the database name in.
Why? Okay, sorry. Okay, thank you so much. Like I think I thought I have changed. Okay, thank you. So we can change it to Vodka Digital for sample load. Yeah, so now I can run it. So now if you see, I have aborted, so it is showing some signal like interrupt. So up to 15 loops over 3 stages and everything it will show, and it's showing as interrupted. So you can think of a scenario, you are trying to hit a call to a server. Sometimes the server will get down. So let's say like my server is down for 30 seconds. So in the 30 seconds, our script will sending you the request and it will be captured as the dropped iterations or interrupted iterations. So now here for 4 minutes, for first 1 minute, I'm going with the 10 users hitting that post call. Then in next 2 minutes, I'm ramping up to 15 users. And then in next 1 minute, I'm ramping down to 0 users. That is, in 4 minutes, I'm going to ramp up from 10 to 15 users and ramp down to 0 users for a particular post call. Now you can see like how many times I have completed hitting the login API. So here you can see, you can visualize and see, like if I refresh, right, you can see some more hike here. It's keep on, it will be going on. So here also, like you can also edit something. You can add one more query also for much visualization. Let's say like I'm going to take HTTP connecting. So HTTP connecting, I'm always giving as mean the average only, like we are selecting, and apply and save. Okay. So then if you want, you can add one more also, and then you can have gauge, and then you can select iterations. So like one iteration, apply, and then save, and you can use some other graphs also here. Let's say like I'm going with the heat map. I'm going to select some measure data received and mean, or else now here I'll choose some other thing now. So instead of mean, I'll go with to have more visualization. So you have like this. So like what are the things you are keep on adding, right? Like it will be shown in some visual manner here. You can also configure like this. Let me add one more thing. Place it here. I'll just add a stat. So stat, we don't have any data. Let's say like I'm just going for HTTP request, or else. Okay. So the graphs also, we need to choose according to our, the metrics, the visualization also, we need to choose according to the metric types I have said, right? Counter, gauge, and those kind of things. Yeah, these are the things these are. So now if you see like it is ramping down, and you can able to visualize the total metrics here. Yeah, so you can see everything here, like I have retrieved the users, so everything. So request failed is 100%. It is not like that means we don't have any request fail. My threshold is getting passed, it is less than 1%, and everything we have given here. Now if you go and refresh, if you see here, there are some spike in your graph. So moreover, since like we have started up this one, like we are still like we are looking into like how you can integrate, how you can analyze precisely all your performance metrics with K6. Maybe like we are planning for one more session in any of the upcoming OTCA for that one. So this is what we have planned, and this is how you can do some visual integrations for your performance testing here. So basically with the normal HTML or graph kind of thing. So you can integrate with one of the dashboards, and you can have it for your project specific or account specific kind of performance testing with K6. Any questions? Like if you have any questions, maybe you can post it in the QA.